Ladies and gentlemen, let's now welcome on stage with a loud round of applause the Vice President Intel Corporation, Mr. Charles Wuischpard, for the keynote address. Make some noise.
I first want to say Namaste, India. My name's Charlie Wuischpard. I'm the Vice President of the Data Center Group and General Manager of the HPC Platform Group. And that means that I'm responsible for the global HPC business for Intel, which includes Xeon, Xeon Phi, our OmniPath fabric, our Lustre file system, and a host of other technologies that you'll be seeing in the future. My career has spanned almost 30 years now, and in IT. And the last 10 of it have been in high-performance computing. And I can't think of a more exciting place to be in IT. I mean, there's a lot of other things going on in the world right now, but HPC for me has been, it kind of wakes me up early in the morning, and I hope it wakes you up too. It's not just the fact that you get to play with and be involved with the development of absolutely leading-edge technologies that end up making their way into many other parts of the industry, but there's also this sort of larger human mission around making the world a better place and supporting researchers and scientists around the world with coming up with new solutions to make life better for us. And I think that's certainly for me and for my team, that's it's just that extra added sauce. And I think that for you all that are choosing to make your career in HPC, I first appreciate that. I encourage you to stay in this part of the industry and actually encourage more people to come in. As I'll talk about later, we have a skills gap. We still don't have enough people focused on HPC to kind of deliver the kind of future that we all expect. I've been in India. This is my second visit to India now, and I was here in May of this year. It's a long trip from my home in San Francisco, and it's because that India is investing in HPC, and of course investment is increasing in HPC around the world. And I just wanted to pick out three areas here. But certainly, governments are investing in HPC. It becomes a national engine of innovation and economic development. I think you'd be interested to know, and I know we show this at our investor conference. So this has gotten wide airplay, and we note that India is invested in the national supercomputing mission. I thought it was interesting. You might be interested to know that, in fact, after India made the announcement, the U.S. increased its investment in supercomputing with the creation of the National Strategic Computing Initiative. And Europe has recently redoubled its investment and is looking to redouble its investment over the next 5 to 10 years in supercomputing as well. And so I think you should feel proud that I think you started something here. It wasn't just China. It was, there's this global investment in HPC to kind of, make sure that the world is a better place. And that's, good for Intel, and I think it's good for you as well. In the middle column, we've got the commercial world. And of course, HPC is widely used in the commercial world in finance, healthcare, manufacturing. But it's still not as widely penetrated as it could be. I note there that only 1 in 10 US manufacturers use HPC. That percentage is much less if you look around the world. And so that's great opportunity for us and great opportunity for improvement and great career opportunity as well. And then, of course, you've got HPC in the cloud, which is becoming a bigger deal. There's a projection that 15 to 20% of all workloads are going to be in the cloud in the future, and that's just increasing. And there are reasons for that, whether it's a skill set issue or an application issue, or you don't have the data center space. But certainly, when we're thinking of where to invest, understanding those models and those cloud models is an important part of our growth story. We showed you saw the video just prior, but I've been showing this every day or in all my presentations over the last year, and this is probably the last one I'll be able to do since we're ending the end of the year. But Intel's been celebrating 50 years of Moore's Law this year, and for about 25 of those years, I think people have been predicting the end of Moore's Law. And I'm here to just say that, based on our investments in process technology and architecture, there is still long life left for Moore's Law, at least through the middle of the next decade and probably beyond. And it's just an exciting time for us. And I think that when you think about the advances in supercomputing over the next 10 years on the road to exascale, largely it's going to be based on Moore's Law. It's kind of 10 degrees hotter up here than it is. Okay. So you saw the video earlier of the Aurora announcement, and I was asked to show this for a reason. If you weren't aware, Intel, for the first time in more than 15 years, was chosen as the prime contractor to deliver what I think will be the largest, most advanced supercomputer of its kind in 2018. We've got a large team, actually, in the process of building this machine, in addition to all of our development work at a product level. This is called the Aurora machine. It's going to be installed at Argonne National Labs. But you can see the specs there, 180 petaflops. Today's top machine in the world is 50 petaflops in about 18 megawatts of capacity. This will be 180 petaflops and 13 megawatts. And of course, you can see that the specs are pretty impressive in terms of scale and performance. Some of the more interesting things kind of at the next level down are that the aggregate memory bandwidth will be up to 1,000 times greater than those in current machines today. And the latency, the latency in some parts of the architecture will be improved by over 1 million times. And so there's a great story here, and it's really the culmination of what's driving a lot of our development efforts. And as you start to look, it's much more than just a CPU-centric design today. It's really a system-centric view that we're taking. And this is the sort of instance of what I would say is our third generation of technology that will be delivered. Our second generation is coming today and over the next year, and you'll hear a lot about that throughout the rest of the day. As part of the Aurora announcement, we announced this, because if you just build one big, fancy supercomputer, it's kind of nice, it has a certain bragging rights quality, but it's not a great economic decision necessarily, and it's not usable by the rest of the world. And so the design point for that system, and what we're basing all of our work on, is to build an architecture that works at all scales, not just at the very top end, but also for a smaller system, right down to a half rack or a full rack supercomputer. And so we announced at the time, and we've really been spending a lot of time, and it was a big part of our supercomputing announcement, the idea that this is part of what we're now calling the Intel Scalable System Framework. And it's that system-level view that encompasses compute, memory, fabric, software, and actually a number of other sort of underlying technologies like silicon photonics. And the idea is that you can now build a system that'll range from smaller to supercomputers, from data-centric or from compute-centric designs to more data-centric designs to accommodate sort of the surge of interest in big data and big data applications, all based, and I think this is an important point for you, on a standard programming model. So if you're investing in your career and you're investing in HPC, you couldn't do better than focusing on the elements of the Scalable System Framework. And you're going to hear a lot more about this, I think, at our 1:30 talk. It's also a way of describing, you can see at the bottom, there's a number of our technologies listed, but it's a way of sort of bringing these all together in a way that's easy to understand both for you, for our users, and for our OEM partners who are building systems based on the Scalable System Framework. And at Supercomputing, nearly all the large OEM partners that we have announced designs based on this framework. So this is just a taste I want to give you. And then lastly, I want to talk about Intel, HPC, and India. I'm going to continue coming to India. We are 100% committed to the national supercomputing mission. It's very exciting. And we've been working closely with, a number of the leadership on NSM. But also, we're basing a lot of our development now on our new products in India. So in Bangalore and Pune, we have our Knights Landing development and our Fabric development that are part of the Scalable System Framework. We're also exploring and enhancing local partnerships around the country. I'm spending the full week here, and a lot of the meetings are really more with our partners around the areas of, enhancing training and education. We're working to help train not just, this, group in the room here, but to really reach the tens of thousands around the country that I think are seeking careers in high-performance computing. We're working with local manufacturers on HPC boards and designs, on, ensuring high-quality cluster deployments. We're in the process of building out innovation labs that'll be used to, benchmark and provide proof points. And then, on the right-hand side here, we're showing that just in 2015, we've made a number of additional investments, in India. We did 41 HPC workshops around the country that reached over 3,000 developers over the last year. Very successful. We did that with our partners. We established 2 Intel Parallel Computing Centers. Let me talk a minute about the Intel Parallel Computing Centers. This has been a big investment for us. Essentially, we're trying to find sort of leading groups of researchers that are working on open source HPC codes. And we want to invest in their work through grant and gift grants. And we've got now 65 of those around the world. And we're continuing to look for more smart people. And if you've got a grant proposal and a set of open source community codes in the scientific arena that are worth investing in, I would urge you to contact us. But we've established 2 now in India. And also, you see that the #1 supercomputer in India is now based on Xeon Phi. So, it's a great track record. We're putting a lot of investment in India and hope to do so going forward in the future. I want to end with one little story, which I think is maybe a human interest story for you. Was anybody aware of the student challenge around supercomputing? Maybe not. But it was a kind of a global hackathon. We'll have to do a better job of advertising it, but we had over 17,000 students participate. And this was over a 5-week period prior to supercomputing. And the challenge was to take a piece of brain simulation code and see who could improve that code the best or the most. And if you did, you won an 6 or 8 week internship to CERN, all expenses paid in Switzerland, which is great. Like I said, over 17,000 people chose to participate, and the one person that won got some wide recognition. And ironically, he was a 25-year-old student, was not a computer scientist by training, but he achieved a result of over 300 times improvement in the performance of the code. So from 40 hours down to something like 8 minutes, I think, or thereabouts. So it's a fantastic improvement for a person that didn't even really have a computer science or programming background. And I thought this was notable when he was asked, what are the tools? What is the best tool that you used to, achieve this kind of result? His answer was his brain. So keep that in mind as you're kind of, we're going to provide all the skills and tools that we can, but in the end, it's your own, initiative and your own, smarts that are going to solve these problems of the future. And I just hope that all of you in the room dedicate yourself to making those same kind of improvements that student did. And I think I want to end with the fact that, if you invest in Intel and the Intel technology roadmap, which I think is very exciting, Intel is going to invest in you and will continue to do so. So I look forward to having a great day the rest of the day. And we've got a number of our world-renowned speakers. So thank you. Thank you for your time.